audio desktop on, audio microphone is on, video feed is on. Okay, good. Everything's on. Okay. Hello.
Hi.
Good evening. How's everyone doing? Can you guys hear me okay?
Yes.
Okay, thanks. Yana? Zahara? Yana, can you hear me?
Yes, I'm here. Sorry, I have a pretty loud toddler in the background, but I'm here. I'm going to turn my camera on shortly.
Yeah, no problem, no problem. And you brought up a good point. I didn't realize that my calendar invite did not get to everybody for the whole semester.
Yeah,
It's
so
quite
yeah, I went
annoying.
back.
I'm sorry.
No problem at all. I figured it out. Thank you, though. I appreciate it.
Yeah, no, I feel really bad. So I'll figure out what's going on with Google Calendar.
Okay.
It's a user error. It's not them, obviously. I'm hoping the first homework assignment wasn't too bad. It's just a start. While we're waiting, since there's only 3 of you, do you have questions on the first project?
I'm planning to come in next Thursday.
Okay, to ask more questions. That's good. Yes, good. I'll be here.
I was wondering, we have to select a paper, correct?
It's not really. I mean, you can find a paper, you can find the data. It's whatever you want. I think it'd be easier for the first project to find a paper. You're not reproducing anything. You're trying to present it in a way. So it's not just one singular paper. It could be a topic related to your interest.
Okay, so like data from, like if I chose the topic of diabetes, for example, I could select like a bunch of papers related to that condition.
Yeah, that is correct. And what I would recommend is be even more specific. So diabetes related to a genre of patients in a certain area, whatever it may be, because you can kind of, you want to kind of narrow where you're going. And I just lost my headphones.
Okay, and the data. Are we like doing problems, or are we just running like statistics? Are we doing anything in
No, so it's very
the data?
it's very specific. So right, the thing that I gave you guys is very long with like the expectation. It's very clear. Like all you're doing is presenting the data. You're not doing the analysis yet because you haven't been taught it, right? So it's like me asking a toddler to run before they can walk. So I'm not saying you guys are toddlers, just my wife's a toddler teacher. So that's what I think of. Yeah, so you're just presenting the data. And so today we're going to talk about how you present data properly and stuff like that. Does that answer your question?
Yes, thank you.
Yeah, you're welcome. And if you're like me, you probably want to get started on the project early. That's how I do things, but
yeah, I'm thinking
in.
about like doing my topic as diabetes, and so I'm trying to gather information.
Yeah. No, that's good. I mean, and some of you are going to choose topics where finding data is hard, and others are going to choose topics where there's so much data. What am I going to do? Right. So that's the typical issue. Those that are coming in, I asked a question, related to the project. So I posted about the first project, and people had questions based on the report or the write-up that I gave. We can't hear anything. I don't know who Apple Love is, so I apologize. I know it's somebody from the class because it was the same person the last time, and I wrote it down because you said you couldn't change it. Is it Leisha?
She just said she's gonna leave and come back.
Oh, thanks for checking. Okay, we'll get started in a minute, but I just want to make sure if more people have questions about the first project.
This is Chelsea. I apologize before it happens. I'm dog sitting a dog who's a barker. So there's okay.
Don't worry. We all have we have kids. We have I mean the advantage and disadvantage. So we might be able to see a kid. We might be able to see a dog or a cat.
Yeah.
This is it's kind of an exciting piece. We get to see a little inside. It's even though we don't get to see each other in person, I know it's funny. Last time I taught this course, you guys are already better about having your screens on, and I don't require it because some of you might be in uncomfortable situations or whatever it may be. But last time I had 24 students in the class, I only got to see 2 people's faces the whole time, and it kind of sucked. A reminder, you still have the opportunity to come in person to meet with me on Thursdays, so when we don't meet in class. And I apologize, there's confusion about what we're doing on those Thursdays, and that's on me. It's not on you. I thought I made it clear, and apparently I didn't, so I apologize in advance. I will be sending more updates throughout the week. I just didn't want to bombard you, because if you're like me, you get millions of emails and you're trying to survive. So questions as we get started?
Yeah, so the class week will begin on Tuesdays and assignments will be due on Thursdays. So if we have discussion posts, we'll have 2 days to do them.
No, you'll get more than that. I'm gonna put the discussion post for next week, tomorrow morning.
Okay, great.
Yeah. No, you'll have way more. That discussion post I thought was up way earlier.
Yeah.
It wasn't. So, and that's why then I was like, okay, crap, I have to give you way more time. So, Because what you guys see on D2L, even when I switch to student, is not the same thing I see.
Yeah.
So, but yeah, I want to make sure you get at least a week, right, for these discussions.
Okay. Thank you.
Yeah, no. And always call out. It's like, this is not up. Let me know. So it's a great question. Thanks. Other questions? Is it Leisha Apple? I can't hear you, sorry, but if you can hear me. Okay. Yeah, I just can't hear you. It's the headphones. I know how it is. All right. So you'll figure it out. By the way, just so if you recall, if you go where your audio is on Zoom, there's a little caret up arrow, and you can choose what your speaker and mics are. And a lot of times I use my internal computer as the mic, but some of you might. It's Lachey. Oh.
Is this working now?
Yeah, it is. And I'm not pronouncing your name.
Okay, great.
Is it Lachey?
Yes, Lachey. Lachey.
Okay.
I can't get my name to change from Apple Love to Lachey. I don't know how to do that.
Yeah, that's what you said last time. So I wrote it down.
Okay.
Yeah, I'm terrible with names, and I had to do the graduate students' names a few years ago for graduation. So you can imagine how horrible that was. All right, let's get started. And at any point you have questions that come up or whatever it may be related to homework, assignments, discussions, you feel like there's not enough communication, you want more, or there's too much, whatever, just like drop it in the chat, or you can even email me at any point. So I want to make sure you at least feeling somewhat comfortable to be open. Come on. Let me share my screen. So let me know that you can see it.
Yes.
Okay, I see some thumbs up. So and then let me see if you can see that. You see that? Which one do you see? That is the question.
Everything, all the slides.
At the very bottom? Oh, well, let's do it that way. I don't really care. As long as you can see it. So today we're going to talk about graphs and what do they look like. And this seems like somewhat trivial, but there's a magic to it in some sense. There's an art, maybe is a better way of saying it. And like, which one do you choose? I'm going to tell you right off the bat, even if I forget it, don't use pie charts. I never want to see a pie chart. They are terrible. Okay. And I'll explain maybe later, but don't use pie charts. It's never. I lose like half the class because I say don't use pie charts. Okay. So let's talk about the paper you had to read. So that's what we're going to talk about. And oops. How did you approach reading the paper? Or a better question maybe is, what did you all think of it? Or the two papers, actually. One's kind of a public announcement.
I start by just quickly skimming them, and even though the first article was much shorter, it was a little dense because it had the charts that I had to figure out.
I usually start with reading the abstract or the introductory paragraphs to figure out what the topic is and what the goal of the paper is.
Mhm.
Okay.
Yeah, same. I start with the abstract too, and then I just like skimming over the paper and seeing what like the subtopics are.
Yeah.
That gives me a good idea of what the paper is going to be about.
Okay. What did you think of the papers in general?
I'm used to reading more like scientific based paper where they don't have a lot of the not a lot of the subsections as Samaya mentioned. It kind of has the literature review and it has like the participants of the study. So this was, I mean, I've seen papers like this where they go into the background detail. And for the homework assignment, I selected a paper like similar to this. So it's definitely not what I'm expecting for, it's not what I'm expecting with all the background information. So, but it's good information.
Yeah, I mean, to be honest, I'll be very blunt. I'm a mathematician, so we don't usually do any of this. I definitely push back on that we should do more of it. But yeah, I agree. Yeah. Other thoughts?
Well, I did come across a lot of research papers as from the very start of the course, I had like two different research articles to write, searching for the articles for it, taking in consideration of research and the review articles as well.
I think you're missing the point. We're talking about the two papers you were required to read for class today, and I apologize. Maybe
Yeah, and this is the Arizona report and the health disparities in American Indians, Alaska 8.
Mhm.
Okay.
Yeah.
That's the NAAN, Native American Alaska Natives. What that means.
Thank you. Yeah, I was wondering about that.
This is kind of new to me, so trying to like figure out the chart. And it's like, okay, what is weight? What is unweighted sample? Blah blah blah. Like that was kind of challenging for me. Like the content was pretty straightforward, but like trying to organize these charts in my own mind, I was like, what is happening with all these numbers?
Mm-hmm.
Yeah, good point.
And I was reading the paper. I really didn't pay too much attention to the numbers, but what I got from the paper is that a lot of the health disparities is rooted in being colonized, and it's similar to the African American population. So it's like it's deep rooted issues that needs to be solved instead of like focusing on like downstream solutions. It's like get to the basis of the problem and promote interventions that can help the population.
Okay. So I guess maybe a different question is, what did you learn from the papers? Tiara already kind of answered that question. But yeah.
I felt like it was surprising because I did similarities, but these specific like more likely to live like less longer, and those are kind of shocking.
Yeah, you bring this up, and again, I warned you that you're choosing the very first paper was based on my interest and my culture and my history, and I will not apologize for that. I do want to say, Yana mentioned that the community-based research is important to increase participation in marginalized groups. Yeah. That's a good one. It's good. Thank you for sharing.
I actually was able to take a course with I can't remember the woman's name who sort of started it, and I think she teaches I can't remember where. Anyway, at San Francisco State University, I was able to take a whole course on community-based participatory research, and it was one of the main things is they spend almost as long as the study, a long time prior to the study of identifying leaders in the community who will help frame the study and craft what is going to be studied. And once they leave, the community owns the study and the paper, and it's not the the university or the professors or whatever, which I thought was really cool because they have like a lot more control of what they're going to do with it. And instead of being like helicopter research, it actually stays in the community.
Yeah, it's an important piece, and I think there's not a significant yet amount of scientists and researchers and public health advocates that are pushing to make sure that the community owns the information, because remember, data is personal, right? So data is not just a number; it is actually has an actual piece. These are individuals that have given this information to support it, but there can be trauma behind that information.
Yeah.
So we have to recognize that could be the case. Just as similar when you have to do IRB reports, right? Or trying to get data, working with participants, you have to protect and understand that you might be putting them at risk. Or bring up trauma, right? That might occur as well.
That's a really interesting point for me as well. In my work, I work with people who are experiencing homelessness in the western suburbs. And one of the things that we were trying to do is like kind of triage house people who's going to be linked to housing, subsidized rental subsidies, first. And it's really difficult to do that because there's no equitable way, really. And we had this long kind of questionnaire that was basically re-traumatizing people, that just asks your homeless history, but any sort of drug use, criminal background. It was horrible. It was awful. I hated doing it. They quickly discovered that it kind of didn't work. Even the company in Texas who created this metric said this is not a good measure. It was never intended to be a tool to place people in housing. Don't use it. We've stopped using it, and it's still incredibly difficult to pick who to help first. But it was awful, especially about reintroducing trauma while people are still many times in the situation. So I'm glad that you brought that up. This is awful.
Yeah, and I bring it up because you're going to be dealing with a lot of data, right? And a lot of times we have a tendency to forget that data has that personal value. So as you're going into exploring, the potential projects or activities that you plan on doing, just recognize that. I mean, for some of you, it might not. It might just be, something that's abstract, but generally it's not. And we're in public health, right? That's our goal. Even as a mathematician, my data still be related to individuals or math education stuff that, okay. So what I would like for you to do is go into your breakout rooms, give you a chance to just say hi to each other and say, like, this professor's lost his mind. And then also discuss, like, I asked, how do you approach reading the papers? So go into the Google Doc. I will provide the link here in the chat again, and just share ways of approaching. And the whole point here is for us to crowdsource ways to guide each other of like what we think is the best way or how we approach it, reading a paper. And I'll give you about 5 or 6 minutes, maybe 7 minutes to just write some stuff up. So here you go. I've created rooms and they are open now.
Are we all typing first?
Oh, hello everyone.
I was chatting, but I had my mute on. I was mute. Hi.
Hello. Yeah, Yana, you were in the same group as me.
Yeah.
2 weeks ago.
Yeah, 2 weeks ago. Well, I like reading papers. Since being an MPH student, I've developed a strange love for reading papers. I don't know. I like to be able to. I understand it more. I think that's why it's not as overwhelming as how it, like in the past when I would see a paper, I'm like, oh my God, this is overwhelming. 15 pages, 20 pages long. But since kind of learning and developing my skill of actually reading papers, I'm starting to like it more. So I always start with the abstract.
Uh-huh.
The abstract, it'll have like a one-liner for the intro, a one-liner for the participants, a one-liner for the hypothesis, a one-liner for the conclusion or the implications. And once I understand that, now I know what to look for when I'm reading this long ass paper. And I'm like, okay, now I know the introduction is based on this. I can kind of now skim through the introduction and I get a better understanding, and I'm not as intimidated when I'm reading papers.
Yeah.
When I first started, I was like, this is really intimidating to read all this scientific paper. So that's how I start. Always with the abstract, and then maybe even I'll even jump down to the conclusion to see what the conclusion is, and then I would
Yeah.
look at the paper.
So I wrote read the abstract first, excuse me, identify the hypothesis and conclusion of the study, and then read the discussion or conclusion.
Yeah.
After reading the abstract. Cool.
Yeah, that's what I do. It's less scary when you do that because you
Yeah.
I think I just jumped in.
Mm-hmm.
Sorry. I think I just jumped in it. I didn't have any strategy. I just was like, oh, I gotta read this, and I went for it. And then I was like, what the heck? And I had to go back and like read it a couple more times because I didn't have a strategy. I don't read papers often. But I guess I need to get to it, huh?
Yeah, this one didn't have a typical like peer-reviewed paper structure, so you definitely had to just go into it, start with the first paragraph about like the history, disparities, and all the background information for the first one, even the second one.
Yeah,
you just kind of have to go into it with no idea, really. Yeah, it's different.
Yeah.
I also look for quotable quotes. I know that's, but I'm also like, I'm immediately like, okay, what's kind of reading it for, which is the juicy tidbits, just that I don't have to find it, continue. And then, in your notebook, part of your computer, write it down or cut and paste, just so I don't have to keep finding it over and over again. That's not the best thing to do.
It's also really good.
Yeah.
Using the read aloud function, especially a PDF version of an article.
Oh my God, I'm gonna. Yes.
The comprehension of the article is like times 10. Like when you read it by yourself, great. But then when you're doing the read aloud function, it's like the way you comprehend it is just, it's like crystal clear. I love, if I have the option for read aloud in a PDF article, I will probably do it.
I do that too. I use Fgjtfvngecbyfvbugggfghiik.
Uh-huh.
To read,
yeah.
Oh, I'm writing this down.
Yeah.
The way I tackled it was just read it from start to finish, and then afterwards, if I didn't understand something, I would just look that up, dictionary, thesaurus, or
that's a good.
Maybe even Wikipedia. I would just look up whatever that one paragraph was talking about.
Yeah.
And then that's basically it.
Well, I do the same thing. I just start reading the article with the abstract, but then rather than directly jumping to the conclusion and stuff, going through it like the way it is, going through introduction, the methods used, and
it's just, I don't know, you gotta ask her to explain it.
I know, I want to hear this.
Oh, we got kicked out, I think.
No, I can hear you.
Okay, so Ivory, tell us what I heard some great things of how you approach reading. Do you mind sharing? If not, that's okay.
Yeah, I could share. I basically say I do like a concept. It's actually called mapping. So as I read words that stand out to me, I make it like the topic, and then I break that topic down into subtopics, and then more and more subtopics. So it's like explaining. Like say for instance, like you got a term, then you have a definition, then you breaking that down into like what are they saying about this term, and what are examples that they're using. So like the reading that we recently did, like for example, I literally got like the word limitations. Can you all hear me still?
You're doing great.
Oh, I literally got the word like limitations, and I put 7 limitations, and then around limitations, I got the seven arrows, and then I put like one of them is like self-reported bias, prevalence equals diagnosis, disease only. So it would just be like words that stand out to me when I'm reading that deals with that topic. I don't know if that makes sense.
No, that was great.
It does. Yeah.
Yeah.
Thank you so much for sharing. And one of the things is part of it is we can learn from each other. I've never done that. So the next time I read a paper tomorrow, I'm gonna try to see what I redid and see how it works for me. You know, and try new ways. Thank you so much. All right.
Yeah, I think it might help me focus if actually writing it down, you know.
Okay.
Sorry.
So let's go back to our PowerPoint. Oh, I'm gonna try this differently this time. So another try. Share my screen. So now you get to see the big one. All right, so what we're gonna do here a little bit is we're gonna review some notation, or and we're gonna start by reviewing what we mean by working with the population, and what does that mean. So one of the things that's very important is understanding who your subject you're working with. Is it animals, humans, plants, whatever it may be, and realize again, Ira was just mentioning about limitations. You can't observe the whole population. Okay. And because you can't observe the whole population, we have to understand that we have to categorize, we're going to take a subset of that population. Either observe it, implement the intervention, whatever it may be. And the way we do this is we call it a sample size. And the notation we use for sample size is N. You know, and we joke. I mean, there are many times I'm talking to somebody, I'm the worst person at a doctor's office or whatever. But when my wife was pregnant with her first child, we went to the hospital and they said, you know, majority or 90% of patients don't experience this. And I was like, can you give me a little more information about the study? What's the standard deviation behind that? What is the N? I mean, I really want to know, because you're telling me not 90% with a plus or minus what? Right. Okay. So you don't want me around. But that is something I want you to start thinking about. What is the N? What is the population? What's the measurement? You know, what is the variance? How much is the data spreading? So if the data doesn't spread a lot, oh, I'm feeling pretty good about that number. But if the data spreads a lot, I'm a little worried. So example, let's say I want to study students. Do I want to deal with 18 public health students, 6,000 college students, or 359,000 undergraduate enrollment students? Who is the population I'm measuring? Who's the population I'm working with? So for example, if I just want to study like something for this course, and I don't want to study everybody in the course, but a subset of the course, right? Then I'm going to be choosing an N of less than 18, right? If I want to study the students at NEIU, right? Would it make sense for me to be studying just this course, or across different courses? And how many courses should it be? How many students? Yes, throw your hand up. Yes.
I've always had this random question where, how do you know what percentage of the greater population to choose, which will equate to a representative sample?
We will do that. It's called a power analysis. So we're going to show how you do that. And to be honest, what it is you say, I don't have a lot of money. I tried it on this, and the N is so small, right? The N is like 10. And then I do all this data analysis, and you're like, what's the error? Where am I avoiding certain error types? So yeah, we're going to answer that. It's a legit question.
Yeah, that is a good question. That came up in the homework assignment, where it's like, one of the questions like, why is this a weak study? And I was like, well, it's only 70 people and they're studying for diabetes. I think the weakness is that it's a small number of people.
Yeah. Well, and
yeah, so that's
that actually 70 isn't that bad.
It's not okay.
No, but actually you saying that is a legit answer. Like that is a legit, like you should say that. that doesn't seem like that many because we know there's millions of people with
Way
diabetes.
more.
Yeah, way more than 1 million.
Yeah.
So example, let's say we want to look at the roots of trees that have Dutch elm disease. Dutch elm disease is a prevalent disease that impacts, trees. That's great. But more importantly, trees are very important from a public health perspective. Why? Well, we know that majority, if you look at green spaces are in predominantly neighborhoods that are wealthy. That's where they're planted, and that's where the resources of the community are spent, is in wealthy communities where they plant trees. What does that do? Those trees provide a decrease in the amount of residents that get asthma. They decrease the pollutants that are in the air, right? So understanding which trees have Dutch elm disease can maybe have us a better understanding of, how they spread, and then maybe we can make sure we're planting a diverse set of trees in non-wealthy neighborhoods. And there's a whole project in the city of Chicago to do this, by the way. So what we do is we have all these trees. I can't study all those trees, can I? But I can take a random sample from those trees, do a study on it, and then I'm going to do some inference. That means I'm going to infer information or try to predict what it represents for the whole population. And then, but the important piece is we're doing this random sampling to infer the information. So sample size versus measurement. I think that's another big question that people get confused from. About. So example, let's say we want to draw blood from 20 people, and we're taking one sample of 20 measurements. Right? We're taking one sample from 20 people. Your sample size is 20 though. Why? Why do you think it's that?
Didn't you say the N always equal to population or something?
Yeah, that it exactly what it is your N is related to the individual of where you're getting the information from. So let's see, how many people are in the class right now? So there's 11 people on the call right now. Mm-hmm. So my N is 11, even if I'm asking all the same question, right? So I have one question for 20 people. This seems trivial. I promise you it's not, because sometimes you read stuff and it becomes confusing.
Wait, are you saying that measurement, like the measure is more like consistent, right? It doesn't change, but the sample can?
Mm-hmm. Yes.
Okay.
I have a question on that. Can't the measurement also change? Can't you get 2 samples from 20 people?
I can. Yeah. But if I get 2 samples, right, it's not, my N isn't 2, my N isn't 40, my N is still 20. So some issues when we get samples, we have bias samples. So I apologize. I know people don't want to talk about election stuff, but you see polls all the time, and you're going to see, and I use this as an example because it blows my mind. It just blows my mind. So you can matter that you take 100 people, you're going to try to say, well, how do you feel about the economy in the United States? But all 100 people are people that answer a landline and live in South Dakota. Do you think I have a right to be able to infer what it feels for the whole United States, or what it feels for South Dakota?
Only South Dakota.
Yeah, because I've biased my sample size, haven't I? I've only selected a certain population to it. So to avoid this, what it is I want to randomly collect information, right? But I have to choose my territory that is hopefully representative of what I'm sampling from. So for election, I want to be making sure that I'm getting enough people across multiple states, right? That are not just rural, that are not just urban, that are just not that are not from small cities to large cities. We want to make sure it's representative across multiple spectrums. And that can be quite difficult. You can imagine how that can be difficult. But you're asking a difficult question. Okay. And again, we try to avoid bias sampling by using random sampling process, a simple random sampling process. So I have the whole population of voting eligible individuals to select from. As soon as I say I'm doing it through a landline call, I've now decreased my sample size, or not my sample size, my population of which to work with. So let's give a formal definition of what this simple random sample is. You're going to take a random sample of n items. Every member of the population has the same chance of being included, right? So if I'm doing that polling and I'm just doing landlines, not everybody in that population has the same chance, do they? The members are chosen independently of each other. So independent of each other means that if I choose Usman for a question, then the next time I ask a question, everybody else has the same likelihood.
What?
Go ahead, ask your question.
No, I didn't quite get that.
Yeah, so what I mean by, so let's say I choose one person in class. I was using Usman, but, and I say, do you have an animal? Right? And next I want a pet. Next I want to ask somebody else randomly in class. I have to choose it randomly such that each of you are likely to be chosen for that question. I cannot now skew, since I just asked Usman, I now want to ask somebody that's in a different row on my viewing screen. I have to make sure everybody has the same likelihood of being chosen. Does that make sense?
Yes, got it.
Okay. Yeah, no, yeah, it's a little funky, but I just want to make sure that you understand this. Okay. So what I would like for us to do is think of examples in your groups, in your breakout rooms, of simple random sampling. When would you see it? Actually, before we do that, maybe I'll give some... yeah, let's do it with the groups first. Okay? So again, it's the same link. And so just throw out, write down and talk about what we mean by this simple random sampling. It could be, say, I want to do an experiment on finding Native American men that live on reservations, right? And heart disease. Then I have to choose, right, an example of how would I a simple random sample from that population. Ivory, there's two of you. This is awesome.
Oh, yeah, I was connected to my phone. Well, I reboot my computer. Sorry.
No, you're fine. You're fine. All right.
I don't miss anything. Sorry.
No, we just solved, all the world's problems. It's okay. All right. So the rooms are open. I'll give you about 5 minutes to kind of.
Hello, everybody.
Hello, we're back.
Hello.
Yeah, I'm still confused. I'm on a website now trying to read what random sampling is.
I think so. We do random sampling here in Wisconsin with our schools, or I guess not random sampling, but it's like our better schools. They do instead of only the kids in the neighborhood, they randomly choose. Everybody gets an opportunity to go to a better school randomly, if that makes sense. So that's kind of what I feel like he's saying.
Yeah.
Like we do a lottery, like you're right on the Apple Love. What's your name again?
Lachey. It's
Lachey, Lachey.
Apple is my nickname for my family, and I just can't get it off.
No worries. Lachey, you're right on that. Like, when you're trying to get your kid into like a magnet school, for example, you put your name in a lottery. And they just randomly, I don't know what system they use, but being selected to go to that magnet school is random. So you put your name in the sample and then do something behind the scenes on a random sampling of some sort, and then you may or may not, but everybody gets a fair chance for getting into that magnet school.
Great. So
that's exactly what I was talking about.
I'm typing this up in the Google Doc. So how to select students for magnet schools. And this is in Wisconsin. And
Chicago, tell me, like here in Illinois, I don't know in Illinois, but Chicago, when you're doing a magnet school for CPS, you do a lottery for magnet schools.
Well, I'm in Wisconsin and we do it here as well. So that's why I brought up Wisconsin. But
so it's
that's
a lottery
exactly the same
that all students participate in to go into, like, is it for magnet high school? So all 8th graders enter it?
So for Chicago, like the magnet schools are part of Chicago Public School. However, you have to be selected to get into it. Like so you just put your name into like a magnet school basket. And then you may or may not get into that magnet school. They just kind of select you and then let you know if you got in or not. But it's usually for elementary school. But I don't know if we have magnet high schools. I'm not sure 100%, but we do have magnet.
We do. We have elementary, middle, and high school. So I think it may be for all.
Okay. That's cool.
That's the only example that I can think of.
As
a random test, a random trial. I don't know.
I guess if you're playing in the casino, when you spin that one machine and the Russian roulette machine, you can rent each number has an equal chance of being selected. Kind of thing.
I think Russian roulette is a different game.
Well, not Russian roulette is a different game, but the one with the spinny thing and when you spin the thing and the things go on. And the ball.
Now I can't think of the name.
And then the ball.
I think it's roulette. I do think it's
roulette, not Russian roulette.
It's
roulette. That's different. Yeah, exactly. And then the ball has an equal chance of landing in any of those spots.
They're just made.
Definitely not Russian roulette.
Okay. I keep thinking of like I get all these texts now because I'm a registered Democrat of like, people who call but that's not random. Well, no, I guess it's random. If I were a participant in a study and I got these texts, I guess it would be random for Democrats with that. I don't know. I'm confused.
I think so. I think that because it is kind of or I'm thinking random inside a subset of a subgroup.
Or like when people call for polling numbers, you just call. But I also feel like there's it's not as random as you think because they usually do landlines. They call at a certain hour where it's just, not many people have landlines anymore.
I have a whole speech about course evaluations towards the end of this semester when they come around. I'm a big proponent for you to be as honest as possible to help improve a course. So you should all take it. But yeah, I guess actually that's true because I'm thinking about the other way. But you might be right because you're randomly sampling the student's perspective, right? I always thought of more of like, this is an opportunity for you to like say what went well and what didn't go well anonymously. That's a good point. I like that. I never thought of it that way. All right. questions about that? It's not as easy as you
I
think.
was explaining to them that I participated in like I think it was a random survey. What they did was I signed up and then they sent me like an electronic form to fill out. They randomly selected people based on a number. Then you got an email back. And they end up sending me like 10 free bottles of dish detergent without like a name on it or anything. And basically, I got free detergent, and then we have to clean, our dishes and stuff with it. And then eventually, like, we met up in person, all the people that they selected, and talked about it, which dish detergent we didn't like, if it made our skin itch, random stuff like that. So,
That's awesome.
I don't know what that type of survey is called, though, but I think it was random because they kind of like selected us based on, they didn't know who we were. It just was like, do you wash dishes? How often do you do it? Like that. I don't know if that makes sense.
Mm-hmm. Yeah, it does. Yeah. Yana, go ahead.
So there's this old movie with Elijah Wood, the guy from The Hobbit, when he's younger, and it's the end of the world, and the ocean's gonna take over and flood the world, and so the government said they have a ship, and people will be selected based on their social security number, randomly selected by their social security number. So people are watching their TV, and they will call you on your phone based on your social security number. So that's how they were able to select like a certain number of people to go onto this ship before the world ended. So in the event that was a world ending, it may not be fair. It may not be random for people who don't have a social security number, but it would be random in the sense that if you have a social security number, then that population being selected would be random.
By the way, your social security number is not fully random, just so people know. Because some of the digits tell you how old, like your time frame of which you're born and location.
Wow.
So there's some hidden information within a social security number.
Okay.
So if you have a sibling, or children or whatever, and they're born in the same area within a certain time frame, you'll see there's a similarity in the number.
Yeah, I noticed that with my sister. Me and my younger sister have like almost identical numbers.
See, yeah, it's crazy. So, yeah, we would hope so. Okay, so we talked about this word randomness. What the heck does random mean? Or how do you even get a true random number? So if we wanted to make sure everybody had a fully random number, right? So how do we do this? So we have many ways to do it, and I don't want to go too much into the details of it. I just want to make sure that you understand. First, there's no such true way of getting complete randomness. Random numbers are generated based off of a distribution. And we'll talk a little bit about distributions later today. But
that like when the balls come out and they say the number. Is that?
Oh, from the lotto.
Is that a large distribution?
No, it's called the uniform distribution, and it's uniform is about as random as it gets. So it means that every number has the same likelihood. Yeah, I think there's a graph that shows like how the numbers of the big lotto are distributed and how often they come up. But I think it's pretty uniform. But how do we do this computationally? Because you personally can't choose somebody random, right? It is very difficult. So I think it was Yana, you were mentioning about like social security numbers. Sure, we'll do that, but then I randomly select that number, correct? And so the way we can do it in R, the command is sample. If you use Excel, it's rand. So every software that you'll ever use has an ability to generate a number, but you do have to be careful that there's some hidden information. So what the word we use here for R, and we're going to do an example. I'm going to do an example with you. But what we're going to do is we're going to say, I'm going to generate 20 numbers, and I'm going to choose 5 of them. And then, but maybe we want them to repeat. And so I have this slide more for you to use as a guide later on. Let's say that you are interested in using R. And so what I'm going to do is I'm going to pull a bar and I'm going to run through what I'm saying here. Okay? So the slide's more of a guide later if you want to look at these notes and stuff like that. So I always tell students there's no such thing as true randomness. All right, let me share my screen of bars. Okay. And you can see actually I'm running code. I coach my 7-year-old's baseball team. I'm trying to get how to randomly generate a lineup so it's equal and fair. And it's very complicated. And so one of the things is, let's say we wanted to see what that word sample does. And it kind of gives you some information here. And it gives you also have this pop-up of what it's telling us. And to be honest, I read this stuff, I'm like, I have no clue what this is all saying. I don't know what's going on. And I'm like, okay, let me just play with it. And that is what my recommendation is. Anytime you're doing something like with a computer, just play. And so what this does is this is going to assign X to have 20 elements. And it's 1 through 20. And let's see how many people are on the call right now. There's 13 of us. So let's do it for 13. And if I assigned everybody a number on the call, and I said, you know what? I want to choose one of you to tell me your favorite color. I say sample of X, and I just want one again. I say X1. Who is it? Whoever number 12 number was given, right? And if I do it again, you'll see it's a different number. So every time you run the code, it will give you something different. And if you're like, well, why can't I just see the output? Why don't we just do this? But you say, well, I want to select 5 of you to take a survey to win $1 million. All right, those people win the $1 million if they take the survey or win all that soap, because I actually do want this soap. But let's say that you have the ability to win multiple times. Right, so let's say, so if I put in this T, it means true. So it allows a repeat of the numbers. Whoever was 9, they should not be able to be in this anymore. Okay. Actually, I was impressed. All right. And then one of the things in R, which is kind of cool, is there are like hidden stuff. So if I want to choose 10 state names, here are the 10 states that I'm going to now survey about how they're feeling on the economy. Yeah, we are going to take, thank you so much for calling me out. Yes, thank you. I really appreciate it. That's on me. All right. Any questions on this? You can't generate a random number. It's very difficult to choose randomness from a population. You will have internal biases. Use computers. Give everybody a number. Do a computer to do it for you. All right. I'm going to stop sharing. And I appreciate Yano for saying, please, we need a break. We need to stretch our legs. I do too. So what do you all think? 10 minutes back at 7:15? Is that too much time, or is that good enough to use as I say with my kids, potties? So biological breaks. All right, 10 minutes.
Oh, we have 1 more minute. So as people are transitioning back. All right. Hello. Let me share my screen. So, one of the things that was coming up here, talking about different ways for choosing our random population and what we're working with and stuff like that. So here's some things to approach it. One way we can do is we can do a sampling frame where we list all the members of the population, give that unique ID code that I was mentioning, giving everybody in class a number and choosing them randomly. Your ID, by the way, your student ID is also not completely random how it's given to you. It somewhat is, but I can tell when you were first ever applied to NEIU based on your ID number in general. So your student ID for NEIU is not, and you probably already knew this, right?
Wow. No.
How can you tell? How can you tell? Is it like the first 3 numbers or something?
No, the first digit will. So if your first digit of your student ID is a 6, then that means that you start later than if it was a 5, right? So it's actually the numbers given as the application comes in. And then if you have a shorter ID number, that means you're very old. It means you were here a long time ago, or you applied here a long time ago. And it's based off the first time you ever applied. So I had a student that was in my Calc 1 class. His ID, he went here back. He was 78 years old, and he got his bachelor's in education back when in his late 20s. So his ID was even shorter than you can ever imagine. So it was pretty cool.
Wow.
And if you've been someplace long enough, one, you just read from a random number. The computer reads it out. You reject the number based on some criteria. So you say, print out all the numbers between 1 and 100 and reject all the even numbers. And sometimes you just pick the population and you close your eyes. I'm choose you. Sometimes you got to do it, or the population picks itself. Or for example, you're talking about a survey. Again, no such thing as true randomness. So the question is, how do we do this in the wild? How do you do it in the lab? I think the lab's much easier. You have a lot more control on what's going on. And what's some issues with this sampling? So what do y'all think? This is the gold standard. Gold, whatever that means, right?
I mean, is there issues with people who sort of self-select, like people who go through marketing studies, or I was like thinking about like all the voting polls that are happening right now, like,
it would also depend like where you sampled from.
Yeah.
Other thoughts?
You want to know how would we do random sampling of a population?
Of any, yeah, it could be about population.
Okay, so over the summer, I volunteered at the Black Women Expo to increase breast cancer screening, and basically the women would randomly walk past the station and we survey. Is that random?
Like a train station?
To reach the Black women, because Black women have a high rate of, high mortality of breast cancer. So in order to increase the screenings, we had to collect data and to get them to show up to Jackson Memorial to get the free screening. Is that random?
Yeah, it is. but it is a little self-selected, isn't it? Do you have the confidence to go up there and fill it out?
Mm-hmm.
Do you have the time to do it?
Another example that I'm thinking about the wow, you gotta have like a map, say for instance, like the Amazon or something, like a map of it. And then you like randomly have like use like longitude and latitude, put it on the
Yeah,
map and go to that spot. That's
That's
what I was
exactly what I was
thinking.
thinking too. I had the same exact thought, Ivory.
that's awesome. I had never thought of that.
Yeah.
Yeah, cool. So yeah, I mean,
I like.
go ahead.
Oh, sorry. I keep think like that idea. 'Cause, like thinking about doing it in Chicago and using R, because then you would get all different types of neighborhoods and hopefully a fair representation of who lives here.
Yeah, this is good. I never thought about it, to be honest, and then like you've blown my mind. So thank you. Yeah. One other approach to doing this work is known as non-simple random sampling. So we were talking about simple. And so what you do, you randomly cluster sample. That means you take an entire group, you assign it to a number, and you. So what we do is, let's say we have. Actually, I already do this in class. What you're doing right now is you've been assigned to groups, right? To breakout sessions for your breakout discussions. You're put into 2 clusters, and then I randomly choose where I go to listen. Okay. And so what I've done is I partition the population into sub pieces, and then I select people based off of that cluster. Another way is called stratified random sample. You divide population into stratas, and what this helps with this, I say here, homogeneous collection of data. The best way I can think of it is if you've ever been in a biology lab, a lot of times we work with petri dish, and let's say I want to take that petri dish and count the amount of E. coli that are growing or something like that. And you break that down into a strata, like a strip, and I say I'm gonna count in that strip, then I'm gonna count in this strip. To be honest, almost everything is simple random sampling, but there are times clustering where it happens a lot. Stratified, actually, we use it in math education. And Tiara, yes, you can find it, and I will actually give you a link to it as well. Okay. So one of the questions I asked is, doing this, will it represent the whole population? No. There's the difference between the random sampling and the whole population. We have a term for this. We call it sampling error. You're always going to have it. You have to have it. You accept it. And your goal there is to reduce that sampling error. Okay. Next, I want to talk about sampling bias. Can we think of an example in the news where sampling biasing might take place? I'm going to give some examples, and then I'm going to have you break out into groups and think about sample biasing. So let's say I want to look at the type of cars that are driven by students at NEIU, and I look at the cars that are parked on campus, but I'm only looking at one section of campus. Well, if I'm doing everything that's over by Lech Walesa Hall, then I'm only going to see that. Or if I do everything at El Centro, it won't represent the whole population because not everybody goes to that part. So it'd be better for me to take a piece from each of the locations. Example of treatment of Ebola virus, where we want to be looking at who takes treatment and the effect of the treatment of Ebola virus. Well, if I'm only picking a certain location, right, of where Ebola is, where you might have an Ebola outbreak, we have to be careful. So one example, the very important piece of this is when the CDC and WHO, World Health Organization, was going in to look at how we treat Ebola, without having cognition of our understanding of structural and cultural pieces, they just went in and said, okay, this is how you treat Ebola. Somebody dies from it, you make sure you burn the body, wrap it up, burn it, and don't touch it. But in certain areas of Africa where the last Ebola virus outbreak was, there's a whole ceremony behind the death of the body for certain cultures where you actually hang around that body, pray with it, wash it. There's a whole ceremony. Well, as soon as you do that, you are spreading Ebola. And when they were talking about how we treat Ebola, they were just focusing on city populations without going into rural communities where their treatment of the body is very different than what it was for the people in the city. Another good example is sampling runoff from rain. If I want to understand if there's byproducts when it's raining outside and let's say it rains, but I'm only taking a sample from a gutter versus the sample from a parking lot versus a sample from the Chicago River, I'm seeing different things, aren't I? So it'd be very important for me to be sampling from different locations. So we have geographic issues. We also have different people's culture and identity that come into play. So what does this mean? It is very difficult to do this well and to avoid biasing. But just because something's difficult doesn't mean that we don't try to do it right. And very many times, NIH and the World Health Organization has not done things right, having an understanding of people's culture. There are many times that we are biased where we select and where we get information. So you have to be quite careful. Questions about this before you go to your breakout rooms and have a conversation about biasing in a random sense. Okay. I'm gonna drop the chat again, the link, just so you recall, and then I will create the breakout rooms. You'll be in different groups this time because we have different people here. So
I think the question in the chat is a question that I also had, but I don't think that'll be a bias if you're trying to get information from that specific group.
No, it's not a bias, but that's a good question. Thank you for seeing that. Yeah. It's a great question.
Hello. Hi.
Hello,
Hi.
everyone.
What are some, I'm just trying to think of biases in public health I've seen when it comes to sampling. I don't really like recall a paper article on top of my head, so I'm just trying to think of examples where it might occur.
Everyone.
Would some biases be just like targeting like one like the south side location instead of doing the southwest north side? And then just providing like resources to like south side instead of just in general? Would that be a bias?
Yeah, that would be like a geographical bias, right? You're like dividing groups between locations between different areas. So I think so, yeah.
In longitudinal studies, I think survivorship bias is a big one because you might actually have people dropping out of a research study or maybe dying or something like that. And so that's survivorship bias.
Right. I was thinking maybe like ask like if you're sampling a group of people and asking them what amount of like fresh produce they buy in a month, not taking into consideration how many grocery stores with fresh produce are available in those areas. I think we kind of touched on that in one of the papers that we were supposed to read for today as well. So I think that would be another example of like a geographical bias where you're not taking into consideration what other factors, other environmental factors are occurring in that area.
Mhm. So basically, are we documenting examples of sample bias?
Yeah,
I'm
like
adding it right now to the document, at least just a little bit. But you guys, yeah, but we're supposed to, I think, document it on the Google document.
Yes, you mentioned the geographic bias. I think that's also with developed versus developing nations. Like in developed nations, you would see um, heart disease and cancer rates as being higher, and in developing countries, it would be just water sanitation, hygiene,
mhm.
could be air pollution, air quality. It could be malarial diseases like, or dengue is a big one in tropical regions. So
Yeah, definitely.
researchers just look at both things. They're never going to look at the same diseases in developed or developing nations. So that's geographic bias, like what Sumaya was saying.
Right. Yeah, no, definitely. If you're looking at um different nations around the world. Yeah.
What about like recall bias? I think where they don't remember or they could possibly provide like inaccurate information or memories.
Or co-bias. That would be from the participant side, correct?
Yes.
Yeah.
I think people who currently have the disease will have an easier time remembering like when they were exposed to it. But if you become healthy and it was in the past, you might not remember your exposure to it.
Yeah, that's something you would have to consider for like sampling as well. I didn't think about that at all.
Yeah. Yeah, that's recall. Yeah.
Yeah.
I guess we're leaving.
Man, there's bias everywhere, isn't there?
Mm-hmm.
Yeah, I hope you realize like it's really hard and difficult to avoid bias. I think we try to do the best we can. I think that's the best way to approach it. Um, it's
Mm-hmm.
it's a hard process, but
Mm-hmm.
if something's hard doesn't mean we shouldn't do it.
Yeah, I think that having this conversation made me not think about bias as a bad thing as I did before this class, but just like understanding that it's something that's necessary or something that's unavoidable
Yeah.
I
and
like
not
that.
necessarily intentional.
And we all have there's also internal bias. You already have internal biases, right? Like I know math is the best. And I'm going to convince all of you by the end of the semester, math is the best. You should have all majored in math. But you know, I tease, but I have to recognize that.
Yeah.
I think we use a point on. All right. So next, I want to talk about non-sampling errors. So questions of being asked during an interview, it can be, you know, a sampling error. Non-response bias, that means you're not getting a response, right? You have like information missing, or misleading data. One of the favorite graphs, I don't have it here, is we see if I graph ice cream sales and crime, we see that as ice cream sales increase, crime rate increases. That's nobody's kids listening right now, but that's bullshit. We know it is. There's something else going on. Right? But people show this all the time. There's a course called Calling Bullshit that a bunch of us mathematicians have been trying to develop at multiple schools, where we look at data and we're like, this is misleading. You're trying to sell me something and it's wrong. And we see this. So, and that's why I was trying to get you to think about how data is presented. Next, I want to talk about variables. So the type of variables or the type of information we're working with, we can think about it into three pieces. Categorical, right? So you can think for yourself your major. Ordinal is like how you're feeling. I'm sleeping. I'm sleepy. I'm not sleepy. So ordinal is like, are you sleepy or are you not sleepy? It's a yes or no kind of thing. And then numerical, your ID, your age, your height, your weight. But within that is height continuous. And what we mean by continuous is, do I have many different numbers I can choose from between the height of 4 feet and 6 feet? Right? And are they all basically connected? Maybe. But age, for example, really is just like, yeah, I'm 40, and then next year I'm 41. There's no in between, right? So we have what discrete means you have jumps of information. Height is, or continuous means like you have a lot of different values you can choose from within a small range. If you recall back to your math course, we think of a function as continuous. So again, what we think about is, what is the variable we're using? Is it categorical, ordinal, or numerical? That is always what you want to be thinking. And the process of analyzing that data and how we do it is very important. So one of the things you're going to see as we get throughout the course is we have all these methods and all these procedures and all these tests that we can do for the data, but we can only choose it based off the type of data we're working with. So the data really speaks to us and tells us what is the procedure or the methodology we use. Next, just a little bit about the units. So one of the things is to remember is you have observational unit. And the observational unit is what you're measuring or what you're sampling. And one of the things that for this course, we have this very specific notation. The data are observed, or data are observed values are all lowercase letters, and the variable that you're trying to measure is the uppercase. So let's say I'm trying to measure the height of all students at NEIU, right? So let's say height is capital H. But I can't get the height of all the students, so I'm going to take a subset of that population, and I'm going to get some data about that. That's lowercase h. Okay. So uppercase is the whole population you're trying to measure, okay, or that variable you're trying to measure. Lowercase is what we are actually seeing. Next, I want to talk about how we present data. And this is actually related to your first project. And what's really important in the first project is that there's processes of how we present data. So I want to talk about frequency distributions, where we have a graphical representation for each of the numbers, tables, bar charts, right? You've seen all this somewhere down the line, but how do we do it well? And how do we do it so that, you know, you mentioned reading the paper, you had this giant table and you're like, I am totally lost of what you're trying to tell me. Can you guide me somewhere? So the question is, how do you choose what is the best way to present the data? And to be honest, it depends. It always depends. And I can't say, well, you got this data, you want to do it this way. No, I have to really understand it. Do you know how many times biologists from the biology department will come in my office, say, I got this data, what test should I be doing, and how should I present the data in a digestible way? I'm like, can you give me a couple days so I can understand the data? So let's look at some examples. So what we have here is a table of frequency of distributions of beats per minute. And let's say we sampled some population. This is a frequency table. This is just a table. Okay. This is a cut from the book. So, but it's just presenting the data, right? Tables are simple. They're easy to look at, but notice what they have at the top. They have you'll have a title. I say what the table is. I have a description for each of my columns, and then it's easy to read. Okay. These are just examples, play examples. Here we have two figures. Figure 1 is a frequency distribution using a bar graph for the number of Skittles, right? And so you can see I have a description of red, orange, yellow, green, purple, and the number of Skittles of that color. But it's very easy to read, isn't it? Next, we have a figure. Now it's a frequency distribution using a stacked bar chart. Right? So the left was just a bar graph. Now we're stacking it because we have information based that we want to represent the difference between men and women. I know it's binary, so I apologize, but this is just a stupid example. And so these are just the preference of men and women activities after work. Okay, don't worry about what the information changed. But are they easy to read? That's the question. All right, we're going to do an activity together, okay? And we're going to see, can we do this in RStudio? And see if we can get some graphs. And we're going to have a little fun with it, okay? And we're going to do this, and we're going to see if we can see where people live. And if you're comfortable, you're comfortable. If you're not, you can just choose one, okay? And so we're taking the class, and we're dividing up into categories. We do north side, south side, west side, and suburbs. Okay. Cautionary tale. I am not from Chicago. Okay. Even though I've now lived here a very long time and it scares me. I have no clue what places are. I know the west side. I know the north side. I know a little bit of the south side. I don't know the suburbs at all. So I apologize in advance. So don't give me names. So I'm going to call it a name. And what I'm going to do is I'm going to do this in R. And so what we're doing is, let's make this big. I want your guys' screen so I can see everybody. Okay.
But first, I got a question. So, like, after you collect the data of like which students stay in which areas in Chicago, would you then also like be able to do demographics with like race, sex, and age, or would that be better for a table?
So what it is once you do in these bar graphs, right? That's what we're going to do here with the bar graph. I would what I would do is try to keep it simple. Don't have too much information on that bar graph. But then if I want to say the percentage of people that live on the north side, maybe I have to have a second bar graph talking about the race of those on the north side, a bar graph for those on the south side, and do a race demographic representation, right?
Okay.
So the nice part about a table, it has a lot of information within the table, but if I want beautiful representation through the graphs, right, or to see a trend, I have to be very careful. So people have a tendency to overcomplicate what the information in a graph is.
Okay.
Did I answer your question? Yeah. All right. So I'm tallying stuff. I'm gonna call your name. Again, you don't have to say what it truly is. So Tiara.
West side.
Joe. Ivory.
Suburbs.
Anant.
Suburbs.
Is it Hiba?
North side.
Merasala.
South side.
Oh damn it! I now have to look at my notes. Apple Love, and I know it's not you. And I forgot.
That's me, Wisconsin.
We'll say that's suburbs. It's Lachey, right?
Yes, Lachey.
Bonita.
I would say west side.
Okay, Diana.
North side.
Chelsea.
North side.
Sumaya.
North.
Zahara.
North.
Zubia.
Yeah, it's north.
Uzman.
Suburbs.
This is so different than what I've ever had. So, all right. So what we're doing here is I'm going to say north side. I'm cheating for a second because I want to make sure I do this right. Let's say north side it was 6. South side was 1. West side was 2. I'm gonna have to look up what it was in previous times I've taught this course. Because now I'm pretty sure it's not. And what we're gonna do is we're gonna put all the data together and call data location. And we're gonna create it into a little piece. And the reason I do this, you're like, why didn't you just put in 6, 1, 2, 5, right? So one of the reasons is, let's say I want to go up to the top and say, oh, I got a new person that showed up to class. Let me now add them, and I can add them to whichever one I want to work with. And then I can update from there. So the next thing is we want to create a bar plot. And the nice part in R is the bar plot's pretty simple. Let's see if it does it for us. And what do we see? Notice I had to stretch it a little bit to get it what it looks like. Right, but if you take it, if you download it, and I'll show you how to do that in a second, then it will automatically do it for us. But notice we're missing the axes labels, aren't we? Right, you want to label your axes, correct? Isn't that like an old school thing to do? So let's do that. Oops. Sorry, does not like these. We don't like them. And remember, I'm providing all this information for you, right? And the sorry, I'm just trying to figure out what the issue is. Oh, I'm missing a parenthesis. Forgive me. So I have locations, number of students, home location for students, and I cheat. I say math MPH because I want to call it that, but I'm biased. And one of the things is what you can do is you can save the image as a PDF. You can copy it to your clipboard. I'm muting you. And so let's say we want to save it as a PDF. And you can give it a name or whatever. We can even preview what it looks like. And I'll show you what that preview looks like here. Sorry, I've lost it. Where are you? Here we go. So what I'm going to do is I'm going to bring you to my second desktop so you can see it a little bit more. So we go here. If you export, you can save it as a PDF, but you can actually preview what it looks like. And this is what it would look like as you save it as a PDF. You can also export it to your clipboard, which allows you to do a copy and paste if you're working in a Word document. And you can save it as any other type of document that you want. Okay. So you can save it, file name, as a PNG, JPEG, whatever it may be. So it's kind of cool how this works. You don't want to see each other like that. Questions? Next thing we can do is we can say, well, you know, it doesn't make sense that you're just doing it as number, right? Maybe you want to do it as percentage of the population, correct? So you could go backwards and you can say, I'm not going to do it all, but I can say, well, we have 6, 7, 8, 9. We have 14 people that filled this out. So I can go up to here and say divide by 14. And so on and so forth. Then go do it for each one and re-upload the code. Okay. And again, you can do this also on Excel. All this is doable on Excel. And to be honest, I think SAS does this easier than all of them, but I don't know SAS.
Will there be like the instructions again, like how to save it?
Not really. I don't have instructions for that.
Okay.
So if you're struggling with it, that's a good office hour time.
Okay.
Or even next Thursday, when I have those open times during class time. I already had 2 people take advantage of that where we spent some good time on R and playing with it. But if you're trying to do it on Excel too, I can help you with that as well. Okay.
Okay.
So I don't want to force you what you have to use. Now, and to be honest, that was feedback from previous times I've taught the course. It used to always be just R. A lot of students pushed back, and we were talking about course surveys. That was a course survey thing. They said they didn't like that they were forced to use R. They preferred to be able to use what they were comfortable with.
I downloaded R already. So.
Yeah. All right. So far we're just looking at these frequencies or the number of events. What if you want to do relative frequency? And that's kind of what I was showing with the example before. We had 14 people that filled out where they lived. Then you just take the amount of times it occurs divided by 14. So what you're doing is you're working really with more percentages. And when you're doing this, I kind of prefer dot plots, but there's many ways to approach it. I think as long as you're very clear on your axis labels and also in the description. And then when you write it and reference it, you want to describe it, what you're seeing. Another way to do stuff is known as a histogram. We're not going to ask for your GPA. You guys, I would never do that. That's rude, invasive, and it's also, you don't want to hear what my GPA for as an undergrad either, even though I have a PhD. It was not very good. So one of the things that you can do is I can take a population. So now what we're doing is we're using cardinal information or variables that says that they have some value, right? The GPA has continuous values between a 0 and 4. You can have a 0 GPA, by the way. And basically what you're doing is you're taking the information and you're bending it. You're bending it into pieces. So from 0 to 1, 1 to 2, 2 to 3, and 3 to 4. Now notice that that last pin there is a little bit different than the rest. It's closed on both sides, right? It includes 3 and includes 4. So it happens. In R, you get a histogram. But the important thing about a histogram is you're taking a bunch of information and you start to see shapes, don't you?
Wait, I think you're losing me. So when you say cells, are you talking about like a block of information, like data?
So let's say I collected everybody's height in class. Okay. And what I'm going to do is I'm going to take that information. I'm going to bin it into cells, into pieces. So imagine I have buckets, correct? And I have a bucket for people that are between the height of 4 feet and 4 feet 6 inches. And then 4 feet 6 inches and 5. And I'm going to say, oh, 5 of you have that height. I'm going to put that all in, right? Then I'm going to say,
you're going to put that into one basket.
Yeah, in that one basket. Okay. And then 6 of you have this height. 10 of you have this height. So I'm putting everybody into a basket.
Okay, so, and the basket represents the cell.
Yes, they do. Yeah. Sorry, the cell, I will change that on future. The reason we call them cells is it's kind of you can blame it on biologists.
Okay.
So no, I don't know who to blame. I'm just teasing. But basically our goal here is to develop a histogram. And the nice part about what a histogram does is where we start to see what we know as a bell-shaped curve, right? And this gives us information. Is it skewed to the left? Is it skewed to the right? And these are messy graphs, but I like that they have the frequency 0 to 100 here. And notice what's going on is a lot of the population is geared towards the top. So you can imagine if I gave a test and I see this, I'm like, hey, you guys all did a great job. Not really. I wish it was like from 80 to 100, but still. So let's skew to the left. What that means is we have some information that's pulling the data, right? Pulling to the left. I had a good GIF of is it to the left or the right? And then to the other one is pulling the data to the right. And one of the questions is, if I change, let's say I didn't do it increments of 5 or whatever it is here is 2. And let's say it was from 30 to 40 was my size. The shape might change. So if that cell or that bend has different increments, so if we go back here, it's not 0 to 1, it's 0 to 5, we might see something different. And you hope you don't. And if the sample that you have is large enough, you won't see a big difference. We will be taking.
Okay, so question: when data is skewed, I think that's how you say it.
Skewed.
Is that like a representation of some form of bias taking place in that data, or it don't have to be?
We don't know. I mean, and that's when we have to go into the numbers and we have to figure out what's going on, and it's something that we're gonna discuss later in the semester.
Okay.
That's a great question. Typically, we don't know, but it could be. It could be that maybe I didn't sample enough people to make sure that I'm getting a full representation, or it could be that I have outliers. And we'll talk about what outliers are. There's a way to do it. The other thing to look at is we have histograms, like the one on the left here is a bell-shaped curve, right? And this is like the typical bell-shaped curve that I think many people have been exposed to. And then on the right, we have what's known as a unimodal skewed. It's not bell-shaped. Or the ones before were unimodal. This is not bell-shaped, sorry. And this is just, it's just a mess, right? The data is all over the place. That's okay. You can have data all over the place. You're not always going to have these pretty, shapes. Some other examples is where we have bimodal, and this is pretty common. So what it is you can imagine the population really kind of sitting in two categories, right? Majority of the population is in two areas. This is quite, I say we see it a lot. We see it in science a lot. In education, we see it a lot where we have a category of students that really understand what's going on and those that are really struggling. And many times we don't have somewhere in between. So what you have is that two distinct subgroups. The graph on the right is an exponential. So this occurs all the time. And what you can imagine is wealth distribution. So the majority of the population on the left, right, has the least amount of wealth. When you have a small percentage of the population, the amount of wealth is decreasing over time. And actually, this is actually what we see in economics. And wealth distributions is this curve. It is not bell-shaped. A lot of people assume it is, by the way. It is not. It's not. So what we're going to do is we'll take our break, and then we're going to do some math. We haven't really been doing math, have we? So is 9 minutes back at 8:10? Is that okay? Is that too much? Yes, no?
That's fine for me.
Okay. Okay. Back at 8:10. All right. There you all are coming back slowly. We're hitting down to the wire, but now we get to do some fun stuff, right? Maybe not. Maybe so. Okay. So what I want to do is talk about descriptive descriptive statistics. Say that 5 times fast. And this is where we have some stuff that I think most of you have seen, or you have seen but you've forgotten. Definitely have seen somewhere, but maybe forgotten. And what we mean by descriptive statistics, oh God, can't say that, is they're a way for us to describe what's going on. Yeah, no problem. So the first one is the center of the data. Where's the center of the data? And we call this the median. So I have an example here where I have 7 data points. 10, 8, 4, 9, 3, 1, 20. Doesn't really matter. But to find the center, we rewrite the data in cardinal order. That means from lowest to highest. So 1 up to 20. And then we find the median is just the middle. Okay? So it's that middle term between. So median is, think of medium of the highway, of the freeway, right? It's the middle of the road. By the way, that's where the name comes from. And in this course, we'll use a squiggly line or a tilde to represent median. At any point, if something's given and it doesn't say that it's the median, but it has the tilde, you should always ask, is that the median again? Yeah, it is. So now let's say that before the data, we had 7 data points, but let's say now that I have 6. So how do you find the middle between 6 numbers, right? When you have 7, you have 3 on one side, 3 on the other, and you had a middle, correct? But if I have 6, I want to take the average of the middle 2. So if I have even, I take the average of the middle 2. So now I'm going to rewrite them in cardinal order, and then I add the 2 values, 7 and 9, divide by 2. So 7 and 9 is 16, divided by 2 is 8. So the median is really taking the data and divided up into 2 equal parts. And what we mean by 2 equal parts is an equal share on each side of that the sample. Next, we want to talk about the mean, the arithmetic mean, sample mean. Okay, I'm giving you this weird summation notation for those nerds out there, like myself, who loves mathematical notation, and I hope that eventually one day you will. But at least you'll have seen it somewhere. And but it's not important that you understand what this fully means. But all we're saying is you're going to add up all your observations and divide by the number of observations. So from the first example, we add all the numbers up, divide by 7 because there are 7 numbers. And notice I'm using squiggly lines. The squiggly lines means approximate. The exact value is that fraction. The squiggly lines is approximate. Okay. And then finally, we have what's known as a derivation from the mean. How far is the data from the mean? And to be honest, I don't use this very often or almost ever. But one of the things that we want to know is the data really far from the mean, right? And we can think about that as like the spread. And we're gonna actually talk about standard deviation in terms of that. Finally, one of the things that's really important is we have what's known as robust or resistance of data. So you can imagine you have everybody's height, and you're like, actually, to be honest, I don't think that's my height. I think my height is something a little bit different. And we add that into our data source. And the question is, does that affect the mean and the median a lot or a little? So if it affected the mean a lot, then that means the data is not robust. So a small change really shifted the mean. If we have a small change to the data set and it changes the median, right? Then, but it doesn't affect the mean too much, then it's robust. So the median will always shift a little bit, right? But the median shouldn't shift too much. The mean is related to the actual data. The median is related to kind of like how the data is spread. So I have the categories very wide or close together. To be honest, I don't know about you. Well, we'll get there in a second. You're not going to have to do any of these calculations by hand, by the way. Okay. Oh, no, so that's a good question. Yana asked, when you say robust, do you mean the amount of data points you have? No, robust is relative if the data point changes, the value of the data point changes. So another example, let's say that I asked all of you how many hours does it take, or how many hours a week do you focus on school? Right? And you're like, oh, okay, it's this much. And then I ask the same question next week. And if those data points shouldn't change too much, but if they change, how much they change and really means is the data robust or not. If it changes a lot, it's not robust. The next thing we want to talk about is box plots. I personally don't use these a lot, but you will see these in some of the papers you read. I was always taught of them as box and whisker plots. So if you're like me, I have a little kitty. I really think of a cat in a box, so I can't help myself. But it's composed of 5 elements. These 5 elements include the median, right? So it divides it up into the upper part and the lower part. And then we have quartiles. And so the first quartile is the median of the lower part. So I take another median. The second quartile is the median of the upper part. And then we have what's known as an interquartile range, which is the difference between the first quartile and the third quartile. Then you have your minimum and your maximum. So you really have 5 points, 5 pieces. Median of the lower half, median of the upper half, minimum, and maximum. So 5 elements. So let's look at an example here. So let's say I have this vector of data. This is just some random data points. I'm not going to have us find the median by hand. Okay? I'm just not going to do it. If you want to do it, you're welcome to it. But should we really do it? It's not a rhetorical question. Okay, I got one no. I guess we're going to do it by hand. Nobody else wants to respond. All right, let's do this. You should all be saying something. I expect people to. I know some of you can't talk, but some of you should say no. Okay. Be loud and proud. It can't be me just. Yes, there we go.
No.
Yeah, let's use our power of technology, please. Okay. Let's go back to R then. No. Oh, somebody found that. That's good. So I called it yield, and so what we're going to do is just say median of the yield. Okay. Very simple, right? Let's say I want to find the mean. Okay. let's say I want to find
So
the.
I got a quick question.
Yeah, please, always yell out. Yes.
Okay, so if this median 8.2.6 changed to 8.3, will this be robust?
So remember, robustness is relative to yeah, it's still robust because it's not changing that much. It's more about the mean. Did the mean change a lot? Yeah, so it's still it is robust.
And the mean change is not robust.
Yeah, if the mean changes a lot, then it's not robust. The median can change, but it's really about I worry more about the mean.
Okay. I think.
That's okay. So this quantile right here, right? What it does is it gives you the smallest number, which is 44.4. And it also gives you the largest number. Should be giving us. How is it? I have to figure out what's going on. But I really want to focus on these three right here. This is the lower quartile. That's your median. This is the upper quartile. Okay. Yeah. Here's your largest number, 110. Okay. So this is your min. This is the 0% is your min. This is your max. And this is lower quartile, median, upper quartile. If we want to find interquartile range, we can do, say, 97.20 minus 64.65. Okay. Next, we want to be able to do a box plot. What do you think the command for box plot is?
Box plot.
Which goes worse it's not, and then I have to Google it, right? Here's your box plot. Do you all see it?
Yeah, I can see it.
It's not very innovative, is it? Sorry, somebody had a question. Yeah, the quartiles. What it does is it kind of tells us. Yeah, so let's look at this graph. So that's a good question. So that dark line that's in the middle here, that's the median. Okay. These whiskers on the outside represent the min and max values. But what happens is sometimes we might have data that's outside, that's known as an outlier. And we're going to talk about that in a second. And to figure out what an outlier is, we actually have to use what are known as the quartiles to calculate what that is. So what we're saying is basically is 50% of all the data is within this little box right here. Right? So between 25 to 75 is 50%. 50% of the data is represented in this box. In general. That was a good question. That was a really good question, actually. So let's talk about this outlier that I've been promising. One thing that I want to get really very, very clear. Don't throw out data. So if you get data that's like, where is this coming from? So I ask people, how many miles can you run? People are like, half, a mile, 2 miles. All of a sudden you get something that's an ultra marathon. It's like, 100 miles? That's definitely an outlier, isn't it? Okay. But should I throw that data out? It's going to skew how things look, and I have to recognize it will skew how things look. But should I throw the data out? Or should I be honest with people and said, we have some outliers within the data that come from people that are ultra marathoners, and this is that information. But if we disregard that data, this is what it is for the general populace that are not part of the ultra marathoner crew. If you don't know what an ultra marathon is, Google it sometime. It's real. So the way we do it, and it goes to the question of where do we use these quartiles. Well, that little what we want to do is say that that little fence thing that we're seeing is 50% more than the length of the box. If it's beyond that 50% more than the length of the box. So let's say my box is here and I do 50% more. If data is beyond that point, we consider that an outlier. So from our data, anything that's below 15.825 or above 146.025 would be considered outliers. This is very abstract, so I think it's better for us to think of an example. So what I want to do, I want to modify the data a little bit. So this 11 right here, I'm going to make it bigger. We're going to do a box plot of this data. And we understand that it's going to shift some values a little bit, right? But that's okay. So here's my yield 2. Let's get that quantile of that just to see what it looks like. So here's our new quantile of the data I just uploaded. Notice that quantiles don't change too much, but notice this is 11 because that's our lowest number. But my median didn't change, did it? Because remember, you're trying to find the value between the two things. So this is the number at the 50% mark. And also notice I changed 160. I added a trick one here. Okay. Let's do the box plot and see what happens. Do you see a difference? So these points here are considered outliers. So the top one is your ultra marathoner, and the bottom one is somebody that doesn't have the ability to run. Right? So I hope you see the box plot is nice because it actually allows you to maybe observe if you have any outliers of data. And your job then is to go into the data and say, oh, what the heck does this even mean to me? Is there something I should really look at about the data? Or did I have some bias in the data too that might have been giving us a rise to these outliers that I didn't take into account? Questions about these outliers and box plots and stuff like that?
No, I don't.
Cool. All right. So let's have a little fun. We did a little bit of math, some basic. I don't want to say the word basic, so I apologize. I shouldn't say that. It's demeaning. Some recall of statistical operations. We will be doing more, I promise, and it's going to be awesome. But let's do our figure of the day. I think you might be able to figure it out. Let's see. I'll break you up into your rooms again. All right, I'm opening up the rooms now so you can discuss. Nope.
Hey everyone.
Hello.
Hey,
So what does he want us to do with the figure?
figure out what the number is and figure out what the figure. I don't know. It just looked like a bunch of boxes of colors to me.
It's beautiful. So if I knew what he wanted us to do, I'd probably be able to answer the question. Well, there goes the question. Figure of the day, if you have already seen the graph, don't give it away. Would your classmates enjoy figuring it out? Start with observation. What do you know?
Types, colors, and numbers.
Is the question in the document?
It's kind of a question, but it's just like, what do you know? But what do you know about the picture? Or what do you know about the Dr. Hipton?
I think what do we know about the picture?
Yes, it's about the.
I guess like.
Yeah.
So just make observations about what we're seeing, then, right?
Yeah. Yeah.
Okay, gotcha. Okay, so
It kind of looks like a broken bar graph.
Yeah. It looks like little Post-its.
Does look like Post-its.
Yeah.
I totally agree.
Mm-hmm.
All right, see what you could come up with.
So
This is meant to be a game.
Okay, so the x-axis is square centimeters. So something that has
In these countries, the square centimeters.
Centimeters.
Maybe it's the land size.
Oh, good. Yeah, I think, but that's square centimeters though. That's kind of small. Square centimeters.
Is it mattresses? Are we talking about mattresses?
Square. What does one square centimeter look like? Let's see. What?
Oh, that's a good question.
Is 1 square centimeter? Well, 1 square centimeter is the size of like your fingernail, your pinky fingernail. So, what is 10,000 of that? So maybe 1 square centimeter is like the size of your pinky fingernail.
If you like make the picture bigger, there's words next to the yellow sticky notes, and the words are like California King, Super King, Eastern King.
Oh, Super King, California.
Right, that's
Texas
why I'm like, are we
King?
talking about mattresses?
Like bed size?
Or the type of mattresses people sleep on in these countries.
Oh.
That's a guess.
But why are there different colors? Like, is the yellow one like the upper quartile? No.
Like twin. What is the other bit? Queen and full
the king
size.
bed, full size, and then California King
Cause...
is like, I guess, the biggest version. This is, I don't even know. United States and Ireland and United Kingdom has the smallest, but Ireland also has the most. Ireland has the most and the least of whatever it is we're looking at.
Okay, I'm gonna Google what size is a king bed in centimeters.
Okay, square centimeters. So square centimeters.
Square. 39,000. I think we figured it out. 39,000 square centimeters is a king size bed.
39,000 square centimeters?
Yes.
Oh, okay.
That's what it gotta be.
But then what do the colors mean? Why are they separating the colors?
So the green would be twin size beds, the blue would be full size beds, the purple is queen size beds, and the yellow. This is what I'm
king
guessing.
size bed. That's a good
Mhm.
option. So I guess the king size beds can range anywhere from 30,000 square centimeters to like the largest,
To almost 60.
like 60,000 square meters.
Mm-hmm.
Are you able to Google what is the size of a twin bed in square centimeters?
Yeah. Let me do that picture for you. What's the size of a twin? Oh, hurry up. 9,000 square centimeters. See, that doesn't match all. It cut us off.
Yeah.
Sorry.
Okay, we have an idea. Our group had an idea.
Throw it out there. Throw it to the wall.
We think that
No,
is,
Lachey.
we think that is it's bed sizes in the different countries.
Okay.
The blue, the smallest,
bed what?
the green is bed, like mattress, like the green being twin, the blue full, the purple queen. Because I Googled what is the size of a king size bed in square centimeters, and it was 39,000.
We didn't cheat. We actually thought it through. We
No,
thought
I'm
it through.
teasing, yeah.
No, that makes sense.
Oh, was that cheating?
A king size bed in Ireland, United Kingdom, is the same size as a queen in the United States.
Are we right?
Okay, I'll give it to you. I'll give you the solution. Here you go.
Oh, I thought we were right.
No, you're really close. It is bed sizes around the world. It's single, double, queen, king.
Yeah.
Okay.
Oh, single, double.
And it's
Single,
based
double.
on, it's not country, it's region, right? Because United States and Canada is kind of a region. Ireland and United Kingdom are a region.
Oh, okay.
Continental Europe is a region.
Single, double, queen, king. Okay, got it. Malaysia, South Africa. We were really close.
It's pretty fun. Any
So
other
it's really how they categorize it themselves. Then it's not like the universal number of a king size bed is this number.
Yeah.
Yeah, it's not. That's a good point. Yeah, I've never even heard of a Texas king.
That's a new one. The emperor is awesome.
Caesar.
Emperor Caesar.
Okay, so I want to get a point across of us doing these because I had you do one 2 weeks ago. Every time we meet, we're gonna have one no matter what. But what it is when you're giving information and showing information, it's good to actually give it to somebody else to look at. Right? If it's a graph, a table, whatever it may be. Do you mind looking at this and see what do you see something? What are you observing? And they might see a different trend. They might see something else going on. Or it might be that you don't have enough information within the table or the graph to actually help me guide what you're trying to tell me. So one of the very important things with this is I didn't really know what the difference of the colors was. I was thinking it was king and queen, as was mentioned, but it was not completely sure. But we don't want to have people guess, do we?
No.
Right.
Yeah. I have a colleague, he's a very, very well-known mathematician. He always says, tell them what you want to tell them. Yeah. And he says this is really important when we're writing too, when you're presenting data. Right. Hopefully that was not too terrible. The figure of the day, I'm hoping you're enjoying these somewhat.
Yeah. Yeah.
That's fun, yeah.
The first one was fun. It get more interesting. My look of they're more interesting should scare you. Only a few more things, and we'll probably end class a little there. But I do want to give time for people to ask questions related to the project. So the last few things I want to talk about is the relationship between variables. So one of the things is we think if it's univariate, it's a single variable, our summary. So we mean, median, mode. Everything we've been doing so far is looking at one variable, right? So we're looking at, yeah. Bivariate is when we're looking at pairs of variables, categorical relationships. Are you sleepy or not sleepy? Are you hungry, not hungry? Numerical values that are in categories. We talked about that bin, right? Taking people's GPA and putting them in cells or putting them in these baskets. I like the baskets, actually. I wrote that down in my notes to use that more often. And the other one might be numeric with numeric relationships. So instead of binning people into categories, into like the GPA A, B, C, here we're gonna compare people's, let's say, different heights, different blood pressure, and stuff like that. So this is bivariate, where you have pairs of values. One of the things is, this is just from the book, is categorical to categorical relationship. So you can, we can represent the data in a bivariate frequency table. And so what we have here is lobsters being raised with oyster chips to practice clamping of claws. So if it's raised with an oyster chips, we have 8 of them have right crushers and a left cutter, a right cutter and a left crusher, and so on and so forth. Instead of an oyster chip, they're raised with a smooth plastic. This is what the output of being raised with that. And then finally, one oyster chip instead of in both claws, we see the following.
Is this like chapter 3 in our book?
Yes.
Okay.
Yeah. One of the things that we can do is we have the ability to graph these into a bar plot. I'm going to do this to show you what it looked like. But again, you have access to do this work using the code here. And if the code's not working, you can always reach out for help, right? So if you're trying to do something that we've done in class and it is not working, you're struggling, please reach out. Take a screenshot or send me the code that you're doing. You can even send me it and say, Dr. Hibno, I'm struggling with this. Can you help me? Can you guide me? Or say, can we meet on Zoom for office hours? Like, yeah, pull it up. Pull up your screen. Share your screen. Let's see where it's at. Oh, I think I can. Right? So we're here to help each other, okay? So let's do this. I will get quicker about changing my screens. I'm sorry. I'm so slow. Let's see if it works. So what I've done here, don't worry about that the legend is overlaying it. So what we've done here is I did a box plot where I basically said, do we have the right crusher, the right cutter, or right and left cutter? And the colors that are established here are based off of if they're grown with one chip, smooth, or oyster chips. And this is a stacked box plot, right? We've stacked the information, haven't we?
Yeah.
No, this should not be here. This is supposed to be in the upper right. So I'll have to figure out what's going on with the code. Let's see what's going on. Okay. I'll figure what's going on there. Okay. Stop share. Okay. Last couple slides and we'll be done. The other thing I want to talk about is what's known as numeric values, but we're in categories. This would be best by doing side-by-side box plots to compare numerical values between multiple groups, right? So you can imagine that I want to compare undergrads and graduates' GPAs. Then I'm going to have a box plot for graduates and a box plot for undergrads. I want to compare blood pressure for early childhood and teenagers, right? I want to put box plots side by side. Okay. And then for numeric relationships, these are usually scatter plots. And a scatter plot, if you recall, is just a bunch of dots, right? We will be covering a lot of this throughout the semester, is this numeric relationship. So I don't have too much on this. Finally, ending note. Continuing working on your assignments, okay? I really want you to focus on questioning data. Question the data. It's okay. Really understand where the data is coming from. Yeah, go ahead, please.
On the syllabus, it says for week 4, project 1 loaded. What does that mean?
Oh, it means it's up. I actually loaded it early because a couple people reached out to me. So it's up there.
Okay, sorry.
No, you're fine. That's a legit question. No, you don't have to apologize at all.
I thought it was like some loaded version of the project.
Oh, no. It's up because if you look at what it says is when the due date is in October, I believe.
Okay.
So, but if you have questions as you're reading through it, say, email me. Please email me. I'm very good with email. I'm trying not to do it on Sundays. So, but if it's like emergency, please, I don't know what's going on. Can you help me? I will try to get to even on Sundays if necessary. Cool?
Yes. Thank you.
You're welcome. Think about biases and, ask questions about the data. Be curious.
Was assignment 2 already up?
It will be posted tomorrow with the discussion for next week.
So next week we have an assignment.
No, you don't have it due. It will just be posted. What you have due for next week is the discussion. That is due next week. You will have, again, an assignment number 2, right, will be posted for you to start working on. And you will have some papers for you to read as well. But that will be due the following week. Yeah, it's a good question. By the way, speaking of papers, if you come across a paper or would like one to be shared or one for us to focus on in discussion for the course, right? Instead of me choosing, send it to me. Say, can this be one for us to discuss as a class? Because I'm pretty sure in your attempt to work on your projects, you're going to come across some interesting stuff. And you say, I think this is one we can discuss as a class together. Send it along. And you get to force your professor to read more. And I get to be excited about your interests. Are you guys okay with me continuing to do a midweek follow-up and check-in?
Yes.
I wanted it to be on Tuesday. Is that helpful?
Yes.
I actually need it. It's beyond helpful.
Okay. I will tell you what happened was I used to do it and a student complained to me and I was like, well, other people find it helpful. And then they complained to the dean.
Oh, no.
And I was trying to avoid, they were saying I was cluttering their emails. So I was like, come on, man. I'm trying to help. So as long as everybody's okay, actually, if you complain to me, I'm still going to do it because many people want it. So just complain to me and I will take it. Okay. So, cool. All right.
Yeah.
All right. Have a good one, please. Get the assignment in. It's due in a couple hours, but most of you have already turned it in. If it's
I'm working on it.
Yeah, I'm working on it.
Yeah, me too. I'm still working.
You're like, that's why we've been so busy during the lecture. We were working on it. No, I'm just teasing. Have a good evening. Be safe out there.
Thank you.
Thank
Bye.
you.
Dr. Hibben. Oh,
I'm right here.
sorry.
Anita,
Let me
I'm
go
right
ahead
here.
and mute something. here.
I have a question to set up office hours for next. Is it Tuesday in between 11 to 12?
I have that time. Yes.
Wait, let me just look at the syllabus one more time.
No, you're fine. I do have that availability. Yes.
Office hours. Could I set an appointment with you?
You don't need a
Tuesday?
set up appointment. Just show. And if you're doing it virtually, just email me and say I'm going to come virtually.
Oh, I'm gonna come virtually.
So as soon as you're like I'm logged on virtually, because what it is I have in-person classes too. And if the student's there, I have my email up that says and so I'm kind of looking out of the corner of my eye, and you're like, I want to talk. I'm in the virtual office hours. I'll pull up my Zoom. Okay.
And it's the same Zoom link we use for class?
No, it is a different Zoom. It's my personal Zoom.
Okay.
So if you go to D2L under Zoom links, it has the one for class, and then it has one for office hours.
All right.
Okay.
Thank you.
Because I want that to be available for all my courses.
Okay, because I had more questions about the project, the first portion of the project that I have to do.
Yeah. Okay. Yeah. Cool. We can talk about it.
All right. Thank you.
Yeah. You're welcome. Have a good night. Bonita, were you able to fix the sound?
Yes. Is that better?
Yeah.
Okay. I just had to log out of my phone. I think I had communicated with you because I had traveled. So I really completely lost track of days and times and things. But I had the same question the previous student had, which was, do I need to send you an email for the in-person next week or just show up?
Oh, in person, please show up. I would love to meet you in person. I would love to help. It's much easier in person. You show up during those office hours. If it's an emergency that I can't be here, I'll let the whole class know. But I'm always here.
Okay. So as far as, because I don't have my personal laptop is a little bit tricky to work with, in terms of downloading some of those softwares that were recommended. Would I be able to use the computer at school, or do you need for us to come? Okay.
The computer at school has them, but you can use Excel.
Okay.
And you can use Google Sheets, and you have access to Google Sheets. You don't have to download anything for Google Sheets. Okay.
Okay. Okay. Okay. Okay.
But I
Okay.
can
I
still
appreciate that. Thank you. Okay. Perfect. Thank you. That's all I needed to know.
Yeah. Well, I'm excited to meet you in person.
I have a quick question.
Yeah, please.
So for the project, I see that it's due on October 10th. So we're gonna have an in-class presentation, and then you want us to upload our slides as well?
No, you're gonna record them.
Okay. Okay, it's gonna be recorded.
But we're gonna have a class discussion about them.
Okay.
So what it is I'm gonna, and I haven't figured out how I'm gonna do this. I used to do it where you have in-class presentations, and we'd always run over.
Oh, okay.
So what I'm gonna do is we're just gonna run over if we do it. If we were in person, I could do it because I can control time better.
Mm-hmm.
Right.
Right.
But so we're gonna have people record it, and then what I'm gonna do is have you choose one or two slides that you think is important and share that
with the class.
With the class. Yeah, I haven't really decided per se. I haven't gotten to a point where I've made that decision.
Okay. Yeah.
Okay.
No, I'll keep an eye out for that. Yeah. All right. Thank you.
You're welcome.
Thanks. Bye.
What's up?
I was listening to mutual questions and answers in case in case you answer the same question I have. So
okay.
Yeah. All right. I don't have any questions.
Okay, cool. And I know I'm going to see you next week, right?
Asking. Yes.
Yeah, and so anytime that you need that extra time, you don't really have to ask. Just email.
Oh, okay.
And what it is I might forget that you get the time, but that's on me. That is not on you, and it's not your responsibility. Okay.
Okay. Thank you.
So, and if the assignment closes, all you have to do is email and email the assignment to me. Okay.
Okay. Also, what I've noticed is, I actually have the third edition of the book is like an ebook, and I actually got the second edition of the book from the library, the school library, and I noticed the particular assignment we're doing is identical. The questions between the two editions and the Framington study.
Mm-hmm.
Yeah, so
I think the first I'd have to look at what the difference is between the third and second, and it should say it in the beginning of the book.
Usually the publishers just add like an additional chapter
Sometimes
in new editions. So there might just be like one chapter which is different. Yeah. So I have a hard copy of the book and an ebook, technically.
Yeah.
I always find that interesting between editions of books.
Yeah, they should say in the beginning what the difference between they are. I'm trying to see. How you now I'm gonna have to.
Also, I am working on with Student Health Services some data collection for the contraceptive vending machines.
Yeah.
By the end of October, I should have a bunch of data. So
you can use that as your project.
Yes, I'm gonna play around in our studio with that.
Yeah. I would love that. I've had a student do it about student survey data that they had an IRB for way in the past, related to mental health, like 10 years ago, and it was awesome. It was one of the best presentations because it was their data that they're playing with. So.
Yeah, and they also have some Qualtrics data. Which
even
they're
better.
doing their own survey, like a climate study, whatever that's called.
Yeah,
so
it's a climate study.
That'll also be at my disposal. I can use that data too.
Ooh.
For Student Health Services.
That should be fun.
Yeah.
All right. Well, enjoy your evening, okay?
Bye.
Be safe out there. Bye.